All right, welcome folks to AWS Security Masterclass. This is session one. We are going to be doing a bit of AWS security introductions, and I'm going to talk about how I space myself when I'm attacking systems on the cloud or otherwise. Right. Um, Today is the first session, and we're going to have 9 more of these over the next 9 Saturdays. My name is Riyaz Walikar. I'm one of the co-founders and chief hackers at Cloud. I look after the R&D team whose research goes into building the product that we have. We're building Cloud for SaaS engineers and infrastructure security teams to help detect assets in the cloud and detect misconfigurations in them and provide continuous remediation measures and guidance so that they save time and don't do security related stuff, right? You want people to go do their own productive product building things. I have over a decade and a half worth of experience, been breaking into stuff since college, doing web applications, mobile, wireless, cloud infra, all of these things, and more recently, container and Kubernetes environments. That's my Twitter handle, and that's Cloudl's Twitter handle for you folks. Okay, I want all of you folks to spend like a minute, but make sure that you read. There's a link that I've pasted in chat here now. Can you folks just take a minute and go to the link? I'll put it up on screen as well. This is a standard code of conduct for online sessions at Cloud. Because we're interacting with people from various walks of life, we want a predefined set of code of conduct to be followed. You can do a thumbs up using the emoji icon at the bottom of your meeting to let me know if you've read through. All right. Okay. So here's how the structure of the masterclass will look like, right? We are going to we have got 9 sessions, right, across the coming rest of the 9 weeks. I want everyone to use their own AWS accounts. This is really critical and important because if you start sharing accounts and if you're using an account that is already shared with someone else, any attack traffic that you generate or any offensive security, any attacks that you mount basically, right, and if AWS detects them, you could have your account banned, right, and you wouldn't want that if it is being shared with somebody else. Okay, so make sure that you're using your own AWS accounts. We're going to focus on a bunch of hands-on. Theory is going to be very minimal, starting from I think for this session there's about 50% theory, and we're going to at the end we're going to configure our accounts to work with the rest of the sessions. But session 2 onwards, we're going to have all of it is going to be very hands-on oriented. So you'll have some documentation to guide you, but otherwise we'll be doing most of it is going to be working with the command line in the AWS console. I want everyone to do the exercises, which is the whole point of this masterclass. We are in a closed room session. We want all of us to be able to run through the exercises and see how the attack is set up and what is the end game for the attacker when working with the different services in AWS. Right? Ask questions. This is really important. Ask questions, share your experiences if you have something similar to offer. Asking questions is really critical because there are sometimes questions that multiple people in the group may have, But for whatever reasons, if you feel you're shy, or if because you're in a room with people you don't know, right? There's this constant fear of being judged. I had that when I was doing security pretty early on. I'd be very scared of asking questions, right? And then eventually I got over it, and I realized that the more I ask, the more I will gain, right? So try and use that to get over any fear you may have of asking questions in closed room sessions. I'll share the slides at the end with the participants who are here today. And remember that the masterclass is focused on AWS security from a hacker's perspective, right? So from my perspective. So the way there's some content that is going to be covered which you may already be aware of, but you're going to see it through my perspective, right? There are concepts that AWS also covers in their documentation, but the way I as an attacker would see it is what I'm going to be offering through the masterclass. Okay, we'll just take a look at the rest of the 9 sessions that we have. You folks have already seen this is on the website as well. Session 2 onwards, we're going to focus on in session 2 we're going to look at IAM misconfigurations. We're going to do some privilege escalation attacks. We're going to see how people misconfigure roles, right? Tokens and policies, etc. Session 3 is S3 misconfigurations. I think this is going to be the most common across all the people who are attending, because there's a lot of content that's already covered over the internet on how to attack S3. We're going to do some hands-on exercises around these, about how discovering and how we go about discovering and attacking S3 buckets and files and stuff. 4 is going to be around EC2s. We're going to look at EBS storage misconfigurations, and we're going to look at in session 5 we're going to look at AMI storage, right? So EBS storage misconfiguration, we're going to do some disk analysis. I'm going to give you we're going to discover a disk, and then we're going to see how we can do some forensic disk analysis on the EBS storage. And AMI storage in session 5, we're going to see how people put AMIs which may actually contain data. We're going to retrieve some AMIs and then extract data from those public AMIs. Session 6 is going to be a mini CTF/hackathon sort of thing, where I will have planted different resources on AWS accounts. We'll discover, and then we'll go through whatever we've learned in the first 5 sessions. 7 is around EC2 misconfigurations. We're going to look at popular ones. We're going to definitely look at IMDS. We're going to look at how it can get exploited with IMDS v2 as well, how we can do SSRF, complex SSRF for that case. We're going to look at what instance profiles are. Session 8 is about Lambda misconfigurations. We're going to look at roles that are overly privileged for Lambda. We're going to see how we can get a shell within a Lambda and then extract temporary tokens from memory. 9 is around RDS. We're going to look at how different different databases are set up in AWS, and what common misconfigurations they can have. We're going to look at what service level stuff as well, and talk a little bit more about how AWS implements RDS and why it is not possible to do some system level operations on RDS as well. And 10 is we're going to have a hackathon around all the things that we've learned in the next 5 of those sessions, and we'll have a certificate for all the people who've attended all the 10 classes. Right? It's not only merely enough for you to have signed up and obtained confirmation, but it is important that you've attended all 10 to receive the certificate. Right? Okay, what I'm going to do today is I'm going to talk about AWS and cloud security in general. I work with a lot of different cloud providers, and as part of the work that I do at Cloud, and any misconfigurations that we do find in all these cloud providers, we then go add into the product. But I'll talk about how I approach and generally what we see, what is the general consensus around cloud security for AWS and others. We're going to briefly talk about the AWS well-architected framework, but focus more on the security pillar and how I interpret the security pillar, the most important part of which is the shared responsibility model. We're going to talk a few minutes about that. And then we're going to look at how the attacker mindset works, right? Why do folks attack stuff, and what are the advantages that attackers have due to how ops and devs and ops and infra folks operate their infra. We're going to see what advantages we have and why some of the things are being done. And at the end, before we close the class today, we're going to get our accounts ready, right? Okay, I have a very simplistic. Okay, I have a very simplistic diagram of what the AWS cloud or general any cloud on the internet looks like. There are about 500 things missing in this diagram, but from an attacker's point of view, it is important to visualize what the cloud looks like on AWS's side using this diagram, right? Look at the cloud data center. Imagine this as your physical, your bare metal box on which everything else runs, right? You have virtual machines running within your bare metal service, and you have your NAS devices, your storage, and you have your other infra, your networking equipment, routing and stuff. There is an API layer on top of this infrastructure that allows clients to interact with the cloud, right? So you're looking at your client browsers, your CLI, your SDK, your API tools. If you use if you're directly making requests using Postman, for example, you're still hitting the API, right? And there are internal management apps that we are not aware of, right? AWS and all other cloud providers in general do not disclose what apps they use with the cloud infrastructure, which is why when you're talking to support, for example, they can see stuff inside your cloud, right? At least the names of the resources and stuff. And there's a lot of metadata that is exchanged between your cloud account and the internal setup that cloud providers have, right? But remember that there's an API layer. That's the whole brilliance about how the cloud operates. For any cloud provider, you take Google Cloud or Azure or DigitalOcean or Linode, any one of these, right? It could be an IaaS or PaaS or SaaS, doesn't matter. There is going to be an API layer that the client interacts with, right? Which eventually allows you to work with the hardware and the software on the cloud, right? It's interesting because as soon as you talk about API being the middle layer, right, it brings about a very interesting approach to how you would go into attacking stuff in the cloud. And as it is a common knowledge, security is the responsibility of both the cloud provider and the tenant owner, right? So when I say cloud provider, AWS in this case, and the tenant owner, you folks, right, is the responsibility of both. And we're going to touch a little bit more about this in upcoming slides. The primary interface to interact with the cloud are APIs, right? And I'll keep talking about this because everything that we will do and everything that we do anyways on the cloud as part of ops or attacking is going to interact with the APIs. You talk about using the AWS CLI, there is still you're going to be interacting with the AWS API, and I'm going to show you an example of that in the next session when we work with the AWS CLI. You can actually send it through burp if you require, right? And you can see the actual traffic that AWS CLI is going to be sending to the server. Okay. Given point number 2, the primary interface to interact with cloud are APIs. Cloud providers are all obviously going to be prone to vulnerability that can afflict APIs. So you may see sometimes people posting about how they discovered a bug within Azure's some particular service, right? What they have done is they've interacted with the API and discovered a bug within how the API interacts with the rest of the cloud infrastructure. Right? So think of it, this is a very complex, very large web application, right, that allows you to interact with the rest of the cloud and have an API interface. So any vulnerabilities that afflict APIs are definitely going to be available to exploit on cloud providers. Additionally, cross-tenant and host escape issues are a big deal within the cloud, right? Why do I say host escape issues specifically is because cross tenant is easily understood. Like you have say Dev's account, right, and you have Akash's account, right, and you imagine if one of you is running a particular service, right, on an EC2 instance and it is in a particular region and it is inside a particular VPC, you wouldn't want that particular service to be visible to a different tenant, right, just because they have the same internal IP address range. That would be a cross tenant access. Right? That's not how the cloud is set up. You have segregations within VPCs and the VPCs are isolated from other accounts. Host escape issues are interesting because there are managed boxes. When I say managed services, these are managed boxes or services that are run by AWS, and what you have is only an interface to interact with the service itself, like say RDS, right, a database. When you have when AWS spins up an RDS for you, you have a MySQL command line that you interact with. You log in into the MySQL interface of AWS RDS, but what you don't have access is to the underlying operating system on which MySQL is running, right? And when we do RDS in the later session, we'll see why this is important, because if you are able to gain access to the file system on which MySQL RDS is running, you would then be able to bypass the host. You would be essentially be able to escape the host and access other tenant data, right? And these bugs have been discovered mostly in Azure before, and people have earned like a lot of money as well using bounties. Binary weaknesses, data leakage, Intel network access, all of these relate to how the tenants are being built, right? You wouldn't want the one tenant to know that another tenant exists. That's the promise of the cloud. Misconfigurations across all services that allow for CI, the confidentiality, integrity, and availability to be compromised, are exploited for data breaches, right? So when we are going to look at different services, we're going to look at the different misconfigurations that they may have, and we will realize that all of these affect either the C, I, or the A, right, resulting in a potential vulnerability, right? Not all misconfigurations are security weaknesses, right? If they affect CIA, then they become a security vulnerability. And most, if I wouldn't say all, but most cloud providers have features and services built in that can be used to harden configuration. Either they may have it in documentation if they don't have a feature or service available, or they'll have a feature or service that allows you to run secure defaults or harden something that's already running, right? And definitely monitor and log any weird activity and alert on any of those activities they meet a threshold. Okay, so the AWS well-architected framework is a popular framework that folks who architect infrastructure within AWS for different services use, and it has 6 pillars. And they're called pillars, but categories as such. They talk about operational excellence. There is a security pillar, reliability, performance, cost, and sustainability. Right? What is of interest to us is a security pillar. Okay, the others are about how you would say optimize cost, or how you would make it more sustainable, or how you would bring in operational excellence and things like that. The thing that is of relevance to us, the security pillar, talks about how you maintain the confidentiality and integrity of data, manage user permissions, and apply the controls that AWS already has, right, to ensure that even if there's a breach, or even if there's a privilege escalation, you would have minimal impact on the rest of the infra. Okay. I've broken down the security pillar and I've added additional things around my experience as well. Protecting the confidentiality and the integrity of data is paramount across all cloud providers, right? And this goes to any system. At the end of the day, whatever processing we do, whatever service we use, whatever feature we have, it's going to operate on some data, right? So you'd want to protect the CNI of data availability as well. You wouldn't want people coming and trashing your data and you worrying about data loss. But the security pillar more specifically talks about data encryption at rest and in transit. Isolation of workloads. So if you have, say, if you have your staging environment, or if you have your production environments, the data for these two needs to be separated, right? Managing account principals and credential data. AWS security pillar talks about it in terms of users and roles, but there's a lot more around that. You see a lot of overprivileged roles in users. Like now, if you go back and look at your organization's AWS IAM accounts, you will see that there are a lot of users, and we're going to see this in the next session as well. You're going to see how users can achieve privileges that they're not meant to have, either because of a role that they have access to that allows them to reach somewhere else, right? Weak credentials. If you have say an RDS service, or there are other services that use credentials in the legacy form. They have passwords and stuff, right? Or even your own AWS account, the IAM account is not, you don't have a password policy that's properly set for AWS. AWS allows you to set a very complicated password policy, which a lot of folks don't do given defaults. As part of CIS hardening, for example, you do it, otherwise no. The weak credential problem is prevalent here as well, right? Any system, as long as it takes credential data, is going to have these standard things. And improper usage of credentials, this is something that we will keep interacting with. You folks, some of you would have already found some keys and tokens within, say, JavaScript somewhere, right? Or it must have leaked through Git or GitHub on your source code repos. And that's what I'm talking about. Improper usage of and storage of keys tokens in source code and service configurations. Right, you compromise an EC2 machine, and then you have a config file which contains the AWS keys so that you could write to a bucket. Right, that's what a service configuration would look like. Establishing controls to detect security events. Few folks do this properly. Logging and monitoring, it can get expensive. I understand, it can get expensive at the end of the day, and most folks work with the assumption that, hey, my controls externally that would prevent an attack are great. Right, but you always need to think about the concept of assumed breach. Right, think about what if an attacker is already here and I'm not aware of. Right, so logging and monitoring becomes key then. Alerting on malicious activity, because logging and monitoring is not enough. You need to be able to alert on any malicious activity that's been discovered. Otherwise, like you have CCTV cameras, but nobody's looking at them. Right. Usage of secure defaults. Most services in AWS, I would say some of them don't have secure defaults. Some of them by default, when you operate a cloud, because of legacy reasons, they use some insecure configurations. We're going to look at that in the upcoming sessions. Preventive controls, so that the attack doesn't happen in the first place, right? And account-wide policies using something like SCP, right, in AWS. As I said, one of the important key aspects of the security pillar in AWS is the AWS shared responsibility model, right? And how many of you have seen this before? Or this is a known concept? Okay, we can raise your hands. There's an option to raise your hand also in the chat here. Okay, great. Right, so the shared responsibility model is interesting in the sense that it's an obvious thing if you think about it, right? If somebody is going to give you their infrastructure to host your stuff, right, the expectation is that you are going to take care of some parts of the security of the entire ecosystem, and the provider is going to take care of some of the security aspects, right? It's just that, there's nothing else complicated beyond this. If you look at the lowest columns inside this diagram, the hardware AWS global infrastructure section, AWS has regions. They have availability zones, they have edge locations. These are physical locations, right? You say US East 1, it's in North Virginia, right? You have Mumbai, you have Singapore, you have different regions. Physical security of these data centers, these locations, is taken care obviously by AWS. You wouldn't want people running and jumping over the compound walls, plugging in hard drives like how they show it in movies, right? That doesn't happen, right? So the physical security of these buildings is taken care by AWS. Coming a little up, you have the actual virtual machines, the bare metal, and on top of which the VMs are running. You have your storage, your whatever internal storage mechanism AWS uses. You have databases, you have your networking routers and stuff that AWS uses. The software for that, the networking components, the memory access, right, the GPU, CPU access, any vulnerabilities that come because of the Intel processor has a bug, right? There's a direct memory access bug. Back in the day, a couple of years, actually quite almost a decade ago, there used to be these attacks where you could pull out a RAM from a laptop and pour liquid nitrogen on it, right? You'd still be able to access RAM, the contents of the RAM, because the state of memory was then frozen, right? And for the lack of a better way to explain this, you could freeze essentially a RAM card and then operate it on a different machine and extract data. And not theoretical, like practical attacks were shown about this. So you can't do that on AWS, obviously, right? Because they take care of the physical security as well as any memory related or CPU, GPU related bugs that may occur. Now look at the blue section, right? That's the customer. That's you. That's you. Anybody who operates AWS accounts. You have anything that operates on top of the infrastructure that AWS has. You may have an AWS EC2 instance, your database, your any of these other aspects that are running on top of the infra. It's your responsibility, right? If you have not patched your AWS EC2 instance, if you haven't done say updates, you haven't installed the latest security updates, right? It is not going to be AWS's responsibility if the machine gets hacked. If you have say Windows RDP or SSH open with a weak password to the internet, right? AWS can't do anything about it because that responsibility of configuring that machine on top of AWS is your responsibility as a customer, right? With RDS, for example, the RDS root password is something that can be reset, right? The first password that is created is going to be complicated, but eventually if you most people go ahead and reset it because paranoia, because AWS also knows this now. Let me just reset the password. You end up setting a weaker password, or you create another user within RDS and that has a weaker password. Now because this is user layer, the customer's responsibility to ensure that this is secure. Any applications you deploy, even Lambda configuration, the Lambda itself having the code having any vulnerabilities, fixing all of those is your responsibility, right? So any security group is the firewall within AWS that you can apply to your services, Lambda, RDS, EC2. The security group being open to the world is your configuration, right? So these misconfigurations can become vulnerabilities because they can be exploited, right? So the shared responsibility model, customers have need to take care of the bits that they control, and AWS takes care of the cloud part, right? The responsibility for security in the cloud and off the cloud. The links I've put in links here. You can also Google for this, available on the AWS website. They have more information around this, but this is interesting to understand at what level of accountability you would have if a breach occurs. Right? And when you do an RCA, if you do a root cause analysis of when and how a breach has occurred, you would realize that whether it was an issue with how AWS has set up stuff or whether you have misconfigured something. And this is true across all cloud providers. Okay? All right. This is where I'll talk a little bit about how I approach different stuff in the cloud. But before I go there, from folks in the audience, how many of you are from offensive security background? Like you attack and you set up stuff, you attack things. Okay, 1, 2, 3. Yeah, web applications as well. Nice. And the rest of you folks, do you come from like an ops background? Do you set up infrastructure, or what's your story? Okay.
Yeah.
Nice. Nice. So we have both. That's interesting, right? So you see in the audience we have both. We have attackers and defenders. Say hello to each other, people. the the important bit, right, for you to understand is that I have this personal belief uh, when I'm just beginning when I'm just beginning an assessment, or when I'm just beginning to attack something, right? I have the firm belief that whatever I'm going to target is going to be breakable. Right? There is going to be a misconfiguration. There's going to be a vulnerability that I can exploit. And that belief system, there may not be a vulnerability that I'll be able to attack and exploit, but that belief leads me to find interesting ways of maybe bypassing something, or I actually identifying issues. It's more a mental thing, right? But I go in with that attitude that this system is going to be breakable. I always think from outside in, right? And most devs and infra folks, the builders in the audience here, usually you folks think about the other way around. You're thinking about going from inside out, right? You set up your server, then you set up the firewall, then you're like, oh, what port needs to be open? Just an example here. Or you have your data, I need to name my S3 bucket this way, I need to put this access control, and then should it be public or private, right? So you're going inside out. As an attacker, I look at things from outside in, right? So I start with what is exposed at the network layer, right? So then I try and identify, if I find an IP address, for example, I'll run a port scan and see what services are visible on that IP address, and then I will do a DNS lookup on that IP address to see if it has a CNAME I can use, right? I identify the IP address is located on AWS, does it belong to Google Cloud or Azure, because IP address ranges are public for all of these cloud providers. I identify what cloud provider it is. As soon as I know it is AWS, I know the target company for which this IP address belongs to has their infra on this particular cloud. That leads me to go look at, maybe they're using S3, maybe they're using RDS, right? So I'm then focused into how the services are going to be configured. The outside in is what I look at. Finding cloud provider weaknesses, and this is true across all cloud providers. Finding a weakness within the cloud provider is far more difficult than finding misconfigured resources of a tenant, right? Does this make sense? It's difficult to find a bug within AWS, right, or within Azure or within Google Cloud, than actually finding a misconfigured resource. I'll give you a very simple example. Imagine you're doing and you're enumerating the list of S3 buckets, right? So you just say AWS S3 LS. This will give you a list of S3 buckets. Now you know this is in your account because you've given the access key and secret to your command line, for example, which is what we're going to set up at the end of the class today. The important bit is that you need to understand that this command will return the same results regardless of the number of times you make the request, right? It is not going to give you the S3 bucket list for, say, my account, right? However, if you have a misconfiguration within S3, the public private lies with you. Those are far more easier to discover than the AWS S3 command misbehaving and giving you data about somebody else's account, right? So again, the shared responsibility model clicks in here, but providing weaknesses, cloud provider weaknesses are more difficult to find than misconfigured resources. And remember, everyone reuses stuff, users, roles, token, keys, even resources. You may have, say, a machine that is set up for, say, an internal routing service, but it will have VPN, it will have, maybe it will be called a jump box, it will have AWS credentials for other machines lying on it. And people, as humans, people like to reuse stuff, right? And especially if you're not doing proper automation about these things, sometimes you'll use the same key across multiple machines, right? A lot of people, I mean, I've not met a lot of folks in the real world who use different keys on every single machine, right? Creating a key itself is a hassle for a lot of people, and then managing those keys, right? So people just tend to have one or two keys in their AWS account, and when you start a new EC2 instance, right? I see some of you smiling, so you know who you are, right? So you tend to use the same key across multiple machines, okay? The service that you gain access may be able to give you additional access, okay? We're using attached roles and permissions. It could have file system secrets. There are environment variables. There's network access through those resources. Imagine you've compromised an EC2 machine, right? The EC2 machine will have roles and permissions that are attached to it that may allow you to escape into the rest of the cloud infrastructure, right? The file system itself may have secrets embedded using configuration files. Environment variables, if user data has been shipped in, or if containers are being used, there's going to be a lot of environment variables available. Network access through the resource. You compromise an EC2 machine using, say, a command execution from the internet, and that EC2 machine then allows you to access internal EC2 machines, right, which may not be exposed to the internet. And this is a sad reality, but devs and infra folks are subjected to business priorities, right? And as for the attackers, this is an advantage, right? The builders in the audience will relate to this. You are definitely subjected to business priorities, which means that you've been asked to build fast and ship faster, right? So you tend to sometimes make decisions that may not align with how the security is set up, right? Credentials can be found in the most innocuous places simply because the secure way of doing something requires additional code or optimization, right? Configurations that are lenient and require less code optimization becomes a choice. And different teams and services, because they're working for large enterprises, you have different teams working together to make one final big product. The misconfiguration could arise in any of those teams, but when you're gluing them together, it becomes a problem of the entire ecosystem. Okay. And most builders don't think about threat modeling when they spin up a service or when they're configuring it. They don't think about, oh, how can this be attacked. They're thinking more about how can I use this in, say, my other service, right? If you have a Fargate container, how do I use this in code, or if I am building a pipeline, for example, right? They will not think to, and RDS is a very good example of this. People start RDS and they have an EC2 machine. Both of them are in AWS, both of them are in the same VPC, but the AWS EC2 instance will connect to the RDS using a public IP address. So the traffic actually leaves AWS, goes out to the internet and comes back inside AWS, right? Which you don't need to, because the EC2 and the RDS are in the same VPC. You can use the internal IP address, right? But again, the lack of threat modeling comes into play here to make those bad choices. The last point. No, so the question here is, should the RDS, the example that I gave, the RDS and EC2 instance, should that be on the same VPC or not, right?
Yes.
As a security best practice, try having them within the same VPC, right? Same region, definitely, same VPC, same region, because you would want to cut down even on the latency. Same VPC allows you to have them connected to each other using internal IP addresses. Right, the host name of the RDS you can internally resolve from the EC2 instance. Right, you don't need the traffic to leave AWS and then come out to the internet and then go back to the machine, which means that your RDS will not have a public IP address. So people can't attack port 3306, right, or 1433, depending on MySQL or MS SQL. Okay. All right, let's get to the last section for today. Can everyone confirm they have, and this everybody needs to do hands-on. I'm going to show you my account here, but can everyone confirm they have a working AWS account enabled for payments? Yeah, Ajman. Oh, okay, you're raising your hand. Okay. When I say working for and enabled for payments, make sure that you can log in as root and navigate to the EC2 dashboard. This is important because if your account is not enabled for payments, EC2 will not show up. You may be able to sign up for AWS, but it needs to be enabled for payments. Show you my account. Okay. Can all of you confirm this? That you can reach the AWS EC2 dashboard? All right. Okay, for this masterclass, what we'll need is we'll need to create a user with administrator access. Okay, I'm going to do that on screen. I want you to follow the steps, right? We will be using this to operate the AWS account instead of using the root user, right? We should not never ever use the root user for daily operations. We're going to create a particular user, and it doesn't matter if you've created one already. We are going to create a fresh one, right? Just so that we have some consistency across all the people here. Just make sure that I'll show you how to do it. This is going to also be used to launch other services, and we will attempt that we're going to attempt to hack in the rest of the classes. Okay, let's go ahead and create this. Then we'll come back to creating the AWS access key and secret for this user. In the AWS dashboard, go to IAM. Okay. Go to IAM. Add user. We call it Masterclass. Okay. Enter the name as Masterclass and click on the provide user access to AWS Management Console. Right, folks. Follow this instructions using the thing I'm doing, the walkthrough I'm doing on screen here. Simply because AWS has changed how the IAM create user interface looks like. Right, you'll realize that when you're creating the access key, it doesn't matter if you've created this in the past, but make sure that you follow the screen. Auto generate a password. This will send you an email, and then you click on next. Okay, it is usually a best practice to create a group, right, attach policies to the group, and then add the user to the group. This is one of the checks within CIS benchmarks as well, where there's a user that has policies attached to it directly. And you should not have. It's easier to manage users if you have a group with the relevant permissions added. Okay. What we'll do is we'll create a group. Okay, so click on create group here, and if you notice, call it Masterclass admins. The first policy here is administrator access. Okay, you're going to select that. Administrator access is the most powerful user within AWS accounts, above which only the root user exists. Right? To give you an idea of what the user has access to, the administrator access is an inbuilt policy within AWS that gives you the ability to perform any action on any resource. Okay, so Masterclass admins is the name of the group. I select administrator access as the policy and I create user group, and then I select the group that I've created. Okay, and then I create user. Done. Yes, no. Okay, if you're done with this, then make sure that you make a note of the username and password and the console sign-in URL. Right? Go to the console sign-in URL, log out from your AWS account as the root user if you've logged in now. Log out and then log in as this user with the new password that has been created. I will do the same. Move this to a different window while doing it. Are you logged in into the new user account? Yes, no, folks. Excellent. Go back to IAM and under users, go to the user account that you just created. While my browser decides to freeze and stuff, what you folks can do is go to IAM under user, go to the user account that you just created. On. Okay. See how the service is designed. Most systems on the internet, most SaaS providers, if they ask you to change the password on first login, they will log you out after you've changed the password. They'll ask you to re-log in. Right here, when you reset your password, it takes you to the home page, the dashboard. Actually logs you in. Different design decisions made during creation of how AWS should operate. But let's go to IAM for now. Let's not dwell there. Let's go to IAM. Go to users. Have the user masterclass. Go to security credentials. Okay, go to security credentials. And under security credentials, scroll down to find create access key. Okay, click on create access key, select, and this is what I'm saying. So AWS IAM has changed how you create access keys and stuff. If you remember earlier, folks who've done this before, when you create an AWS user using the console, you can actually create the AWS access key then and there in the same step, right? But now they've changed the way this works. So under create access key, it will ask you to choose what is your requirement, why you creating access key, because I want to. So I just say other. My use case is not listed here. Definitely the learning to hack and masterclass is definitely not listed as one of the use cases. So we're going to do other and go next. Give it a description. This is useful. Describe the purpose of the key created for the class. You could use any naming convention, any tagging convention you have. I usually do a what is the value key value pair. So I do what and then colon and then the value. So created for colon masterclass, created by colon Riyaz, for example. Okay. Once you've done this, click on download CSV. You would have generated an access key and secret. Okay. Click on download CSV. right? Has everyone got the CSV downloaded? Or basically, do you have the access key and secret with you? Okay. Now what we'll do is open terminal. I'll give you the link. Get this. But yeah, does anyone not have the AWS CLI installed on their system? Everybody has the AWS CLI installed? Okay. Couple of folks is not installed. The for this, it's in the deck, but I'll paste it here. Install the AWS CLI. While the AWS CLI is being installed for the other folks, folks who already have this, you need to create a new profile for this, right? So what we're going to do is we're going to do AWS configure hyphen profile. We'll call it Masterclass. Enter the access key. Enter the secret. Default region will do US East -1. US-East -1. Output format none means JSON. Alright, can you confirm? Can everybody do this? AWS configure hyphen profile masterclass. Any Windows users here? US-East 1. US and East 1. It's there in the slide as well on screen.
I have a question.
Yeah.
Why is it?
It's not important. We're just making ensuring some consistency between all of us, right? Usually if you're comfortable with any other region, it's a preference thing, and US East one will have all services running, because it was the first region that AWS had started, so the uptime and everything else there is going to be better. But it's mostly a preference thing, because this is offensive security session. You can have any region, right? But when you're going to if you're going to be setting up something for your business, then you'd want to work in the region that is closest to where your customers are, right? And there's also the case of GDPR, for example. If you have a region that's in London, and if your customers are in the US, right, or the other way around, so you would want to be a little, you want to think about where your region is going to be. Lost my terminal window. Okay, if you've configured, then what you can do is you can run the last three commands. Export AWS profile, so that you don't have to keep typing hyphen profile masterclass. You can just export that to become your default profile, and then the last two commands, which will confirm that your account has been set up properly. Take a look at the last two commands. I'll just show it here. Over a period of time, you'll accumulate a lot of profiles, right? So imagine I'm sure some of you will have more than one profile on a system. For folks who are doing this for the first time, you'll have default and this profile, right? Actually, you'll not have anything default if you're installing it for the first time. You'll have only one profile, which is Masterclass. Okay. So if I do AWS STS get caller identity, I call this as the who am I of the who am I command of the AWS CLI world, right, or the AWS world. Basically, this tells you who you are, that is accessing AWS APIs. What is your username, right, and what is your account ID. If you notice, I've provided profile masterclass. If you don't want to do this, you'll have to end up doing this for every single command, like S3, LS, then hyphen profile masterclass. Sometimes you'll forget, sometimes you will miss hyphen profile masterclass, and then you'll end up executing the command in a different profile, right? And this is not, when I say different profile, you're actually executing it in a different account if the profile is not belonging to the same account, right? So we'll not do that. We'll simply export AWS profile to masterclass. This makes it really easy for us to then simply say AWS STS get caller identity, and there's no need for profile. I can hit enter, and then it will tell me I am the user masterclass. Okay. Homework for you folks is to enable autocomplete. Right, for me, AWS STS, if I do tab, it auto completes. Okay, it's really useful. If I'm, for example, if I'm doing AWS EC2 and I know there is a describe command I want to run, but I don't know the full details, so I can do describe and it will tell me. Right, very useful when you're working with the CLI. Okay, so we have SCS, I know I am user Masterclass. Is everybody done with this? Yes, no, thumbs up, thumbs down. Okay. So that was the last bit of what we were trying to cover. The question that one of you asked, interestingly, if you run AWS account list regions, you'll see the list of regions that AWS supports and is enabled. Okay, there are some regions in AWS that are enabled by default. There are some regions that you have to opt in, right? Like the Middle East, for example, like or there's a region in Dubai, for example, that you have to enable, right? Or Africa, right? You have to enable, you have to opt in into that region, and only then that region is going to be enabled. Cool. STS get caller identity is the command that you'd want to use, especially if you've obtained new credentials, if you've stolen, if you've recreated, doesn't matter. But if you've obtained credentials, you configure them quickly and then you run STS get caller identity. It tells you who you are and what account does this belong to. All right, that's all for today. We're going to start attacking more specific services, as you saw, in subsequent classes. And you can always reach to me on Twitter, and my email address is here if you have any specific questions around what we covered today, which I don't think any of you will have questions today, but if you do, please make sure that you reach out to me on this email address. There's an academy that we have where we keep posting a lot of deep technical content. See if any of those articles are useful to you folks. We've received feedback that the academy has helped people resolve like troubleshooting issues within their cloud infra. Right, so see if it's useful. You'll learn a couple of new things there as well. Let me just